Chapter 13, Aggregate Demand 1, Building the IS-LM Model. In this section, we discuss the goods market and the IS curve. Let's look at how the economy behaves in the long run and the short run. Long run, prices are flexible, meaning they adjust to supply and demand. Output is based on production factors and technology, like Y equals a function of K, L, and A. Finally, unemployment equals its natural rate. That means there is no cyclical unemployment, only structural and frictional types remain. Short run, prices are fixed at predetermined level. Output depends on total demand, like Y equals C plus I plus G plus NX. Lastly, unemployment is negatively related to output, as described by Ucon's law. This tells us that as output increases above its natural level, the unemployment rate falls below its natural level, and vice versa. Here we examine the Keynesian cross, which is a basic model that helps us understand how income or output is determined in a closed economy. In a closed economy, total income is determined by total spending. This is known as the expenditure approach to output determination. Let's define notation and definitions. I is planned investment. PE equals C plus I plus G is planned expenditure. Y is real GDP or actual output, also called actual expenditure. If firms produce more than people plan to spend, inventories build up. If they produce less, inventories run down. This difference is called unplanned inventory investment, equals Y minus PE. That means firms adjust output in response to these changes. Consumption depends on disposable income, which is income after taxes. C equals consumption, a function of Y minus T. We treat government spending and taxes as fixed. G equals G bar and T equals T bar. Investment is also treated as fixed, exogenous for now. I equals I bar. Using these assumptions, we write planned expenditure as PE equals consumption, a function of Y minus T bar plus I bar plus G bar. The economy is in equilibrium when actual output equals planned expenditure, Y equals PE. This is the key equation of the Keynesian cross. It tells us that output adjusts to match planned spending. Let's review these graphs. Top left graph shows the relationship between income Y and planned expenditure PE. The equation of the line is PE equals consumption, a function of Y minus T bar plus I bar plus G bar. The line is upward sloping because as income rises, consumption rises. The slope of the line is the marginal propensity to consume, MPC, equals delta C over delta Y. For every extra dollar of income, only a fraction, the MPC, is spent. Top right graph, the 45-degree line, simply shows the line where PE equals Y. This is called the actual expenditure line. At every point on this 45-degree line, planned spending exactly equals actual output. Bottom graph, finding equilibrium and inventory adjustments. This is the most important graph. It combines the planned expenditure line and the 45-degree line. The intersection of the two lines shows the equilibrium level of income, YE. If the economy is at point Y1, then Y1 is greater than PE1. It is unplanned inventory accumulation. Firms are producing more than households, businesses, and government plan to spend, so inventories rise. Firms respond by reducing production, causing output to fall toward YE. If the economy is at point Y2, then Y2 is less than PE2. It is unplanned inventory depletion. Spending is higher than output, so firms see inventories fall. They increase production and income rises toward equilibrium YE. When the government increases spending, it shifts the planned expenditure line upward. In the graph, point A is the old equilibrium, PE1 equals Y1. After G increases, the planned spending line shifts up. Point B becomes the new equilibrium, PE2 equals Y2. This causes output Y to rise. The economy moves from Y1 to Y2. Thus, an increased change in G causes an increased change in Y. How much does Y rise? Start with the equilibrium. Y equals C plus I plus G. Take the change in each component. Assume investment is fixed. Since the change in income affects consumption, delta C equals MPC times delta Y. Substitute delta Y equals MPC times delta Y plus delta G. Solve for delta Y. Delta Y equals 1 over 1 minus MPC overall times delta G. Then delta Y over delta G equals 1 over 1 minus MPC. The formula delta Y over delta G equals 1 over 1 minus MPC represents the government purchases multiplier, also known as the spending multiplier. Example, if the marginal propensity to consume MPC is 0.8, then delta Y over delta G equals 1 over 1 minus 0.8 equals 5. This means a $1 million increase in G leads to a $5 million increase in Y. Why is the multiplier greater than 1? At first, a rise in G raises Y by the same amount. Delta Y equals delta G. But then higher income Y leads to more consumption C. Y increases causes C to increase, which causes further Y to increase, which then causes further C to increase, which then causes further Y to increase. This chain reaction continues with each round of spending getting smaller. So the total increase in Y ends up being much larger than the original increase in G. A decrease in taxes increases disposable income. Higher disposable income leads to more consumption. The planned expenditure line shifts upward. In the graph, point A is the old equilibrium at Y1, point B is the new equilibrium at Y2. The vertical gap between the planned expenditure lines is MPC times delta T. Thus, a decrease in delta T causes an increase in delta Y. Solving for the change in income, delta Y, start from the equilibrium Y equals C plus I plus G. Taking changes, assume delta I equals 0 and delta G equals 0. Since the change in taxes affects consumption, delta C equals MPC times delta Y minus delta T. Substitute delta Y equals MPC times delta Y minus delta T. Solve for delta Y equals minus MPC over 1 minus MPC overall times delta T. Then delta Y over delta T equals minus MPC over 1 minus MPC. The formula delta Y over delta T equals minus MPC over 1 minus MPC represents the tax multiplier. Example, let's say the marginal propensity to consume MPC equals 0.8. Then delta Y over delta T equals negative 0.8 over 1 minus 0.8 equals negative 4. This means if taxes T fall by $1 million, income Y rises by $4 million. The tax multiplier is greater than 1 in absolute value if MPC is greater than 0.5. It shows that a small tax cut can lead to a larger increase in income due to the chain reaction in spending. However, it is smaller than the government spending multiplier because people save part of the tax cut, 1 minus MPC. So a tax cut leads to less immediate spending than a direct increase in G. The IS curve stands for investment saving. It shows all combinations of the interest rate R and output Y, where the goods market is in equilibrium. In its context, equilibrium means actual output equals planned expenditure. The equation for the IS curve is Y equals consumption, a function of Y minus T bar, plus investment, a function of R, plus G bar. Here's what each term means. Consumption, a function of Y minus T bar, means consumption depends on disposable income. Investment, a function of R, means investment depends negatively on the interest rate. And G bar means government spending is fixed. Again, the IS curve shows the relationship between the interest rate R and output Y that keeps the goods market in equilibrium. The key idea is that a decrease in the interest rate leads to an increase in investment, which causes an increase in planned expenditure, resulting in an increase in output. This is why the IS curve slopes downward. In the top graph, we start at point A, where the interest rate is R1, investment is IR1, and equilibrium output is Y1. When the interest rate falls to R2, investment increases to IR2, shifting the planned expenditure line upward. This raises equilibrium output from Y1 to Y2. This is shown as a movement from point A to point B. In the bottom graph, we plot this result as 1 point on the IS curve. At R2, the new equilibrium output is Y2. Repeating this process for different interest rates gives us the full downward sloping IS curve. After all, the IS curve slopes downward because a lower interest rate boosts investment and output. When the interest rate falls, firms increase investment. This raises planned expenditure, which leads to higher output Y to restore goods market equilibrium. We can also use the ISLM model to analyze fiscal policy. Fiscal policy affects planned expenditure and shifts the IS curve. For example, G increases or T decreases, then IS shifts right. This helps us understand how fiscal policy affects aggregate demand and output in the short run. We are now examining the effects of fiscal policy on shifts in the IS curve. When government spending increases, planned expenditure rises, which increases output and shifts the IS curve to the right. In the Keynesian cross diagram, we start at output Y1. An increase in G shifts the planned expenditure line upward. This causes equilibrium output to rise to Y2. The change in income or output is given by delta G over 1 minus MPC. In the IS curve diagram, at a fixed interest rate R bar, the rise in income or output causes the IS curve to shift rightward from IS1 to IS2. The size of this shift is the same. Delta IS is delta Y equals delta G over 1 minus MPC. In this section, we discuss the money market and LM curve. The LM curve comes from the money market, which shows how the interest rate is determined by the supply and demand for money. According to the theory of liquidity preference developed by Keynes, the interest rates adjust to balance the demand for money with the supply of money. The money supply is assumed to be fixed by the central bank. In real terms, adjusted for prices, this is written as M over P with superscript S equals M bar over P bar. This means the supply of real money balances does not change with the interest rate. It appears as a vertical line in the money market diagram. The demand for real money balances depends on the interest rate. This is because holding money has an opportunity cost, the interest you give up by not holding bonds. M over P with superscript D equals liquidity, a function of R, where M over P with superscript D is the demand for real money. Liquidity, a function of R, is a decreasing function of the interest rate. Higher R means lower money demand. Equilibrium in the money market occurs where money demand equals money supply. The interest rate adjusts so that liquidity, a function of R, equals M bar over P bar. At this point, the interest rate is stable and the money market is in balance. The Federal Reserve can raise the interest rate by reducing the money supply. A smaller money supply shifts the vertical money supply curve leftward. This causes the equilibrium interest rate to rise. MS falls, then R rises. This is how the Fed raises the federal funds rate, by tightening monetary policy and reducing liquidity. The equation for the LM curve is M bar over P bar equals liquidity, a function of R and Y, where M bar over P bar is a real money supply and it is fixed, and liquidity, a function of R and Y, is money demand, depends negatively on R and positively on Y. As output Y rises, people demand more money. To keep money demand equal to a fixed money supply, the interest rate R must also rise. That's why the LM curve slopes upward. As output Y increases, people want to hold more money for transactions. This shifts the money demand curve to the right. In the left diagram, when output rises from Y1 to Y2, money demand increases from L, R, and Y1 to L, R, and Y2. With money supply fixed, this causes the interest rate to rise from R1 to R2. In the right diagram, this relationship is plotted as a point on the LM curve. Higher Y leads to higher R. Repeating this gives the upward sloping LM curve. The LM curve is upward sloping because when Y rises, money demand rises, but the money supply is fixed, so there is excess demand for money. The interest rate R must increase to bring money demand back in line with money supply. Here we are examining the effects of monetary policy on shifts in the LM curve. When the central bank reduces the money supply, the supply of real money balances M over P shifts to the left. In the money market graph, left side, the vertical money supply line shifts from M1 over P to M2 over P. At a fixed level of income, this creates excess demand for money. To restore equilibrium, the interest rate rises from R1 to R2. In the LM graph, right side, this change causes the LM curve to shift upward from LM1 to LM2. So a decrease in money supply shifts the LM curve upward or left. This section introduces the short-run equilibrium in the IS-LM model. It shows how the economy reaches equilibrium when both the goods market and the money market are in balance. Short-run equilibrium occurs at the point where the IS and LM curves intersect. IS curve, goods market equilibrium, that is, Y equals consumption, a function of Y minus T bar, plus investment, a function of R, plus G bar. LM curve, money market equilibrium, that is, M bar over P bar equals liquidity, a function of R and Y. At the intersection of the IS and LM curves, the goods market is in equilibrium. Actual output equals planned spending. The money market is in equilibrium. Money demand equals money supply. This gives us the equilibrium interest rate and the equilibrium level of income or output. We now begin the quiz on the Keynesian cross and the IS-LM model. Question number 1. This question uses the Keynesian cross model. Given MPC equals 2/3 and delta G equals 120. The spending multiplier is 1 over 1 minus MPC equals 1 over 1 minus 2/3 equals 3. Then delta Y equals spending multiplier times delta G equals 3 times 120 equals 360. The correct answer is D, $360 billion. Question number 2. This question uses the LM side of the model. Given M over P with superscript D equals 2200 minus 200R, M equals 2000 and P equals 2. First, calculate the real money supply. We get M over P equals 2000 divided by 2 equals 1000. Then set money demand equal to money supply. We get 1000 equals 2200 minus 200R. Solving for R, then we get R equals 6. The correct answer is C. R equals 6%. Question number 3. Which curve shifts when fiscal policy changes? The correct answer is D. IS curve. Fiscal policy affects planned spending, which shifts the IS curve. Question number 4. Which curve shifts when monetary policy changes? The correct answer is A. LM curve. Monetary policy affects the money market and shifts the LM curve. Question number 5. What does the intersection of the IS and LM curves represent? The correct answer is C. The goods market and money market are both in equilibrium. This point determines the short-run equilibrium values of output and the interest rate. In this chapter, we built the ISLM model to explain how output and interest rates are determined in the short run. We saw how the IS curve reflects equilibrium in the goods market, while the LM curve represents equilibrium in the money market. Together, these curves show how fiscal and monetary policies affect aggregate demand. Understanding this framework is essential for analyzing short-run economic fluctuations and for evaluating the impact of policy decisions on national income and interest rates.